Hello, everyone. My name is Ryan King. I'm a senior solutions engineer at Flipside Crypto, and I specifically focus on our blockchain infrastructure. And I'm going to talk a little bit today about Flipside's journey through the different observability products in the landscape, how we settled with the Grafana Cloud, and then some of the best practices and strategies that we developed over the past few years of building out our observability system. So to start off with a little bit about Flipside and what we do, is we started in 2017 with the mission of doing two things well. How do you ingest data from a blockchain network into a format that is easy to use by traditional analytics tools? We solved that by building a custom ingestion system to load blockchain data into a Snowflake database. And then the second thing we wanted to do was how do we use that data to actually activate different users in different blockchain ecosystems and drive growth to different projects and chains. And as we started partnering with all these different ecosystems, we developed the need to start running some of our own blockchain infrastructure internally. And that's where I come in. I started as a back-end software engineer and then did a lot of networking and home lab stuff over the years. And then 3 years ago, when the need to run blockchain infrastructure at Flipside came, the team I was on decided to take that on ourselves. And here we are today. So I'm going to start off pretty much how I start off every conversation in my life, which is explaining what blockchain is. So unlike a traditional centralized application where there's one single entity in charge of all of the servers and all of the application code, like Grafana Cloud, for example, blockchain takes a decentralized approach where independent node operators run the software on their own hardware. They all talk to each other through a consensus protocol, and they come to agreement based on messaging between each other. This means that no single person is responsible for the blockchain network, and it allows users to trust that their assets are stored securely, and they can always rely on using it. So to talk a bit more about where the blockchain infrastructure fits into Flipside is really in two critical places. The first point is our RPC nodes. This is the source of truth for where all the data in the blockchain comes from. Think of it like as an API gateway for a blockchain. You can turn on an Ethereum node today on your laptop, connect it to the network, and then all of a sudden you have a local API gateway to get into the entire Ethereum network. You can broadcast transactions, but what we use it for is reading them. The RPC nodes are the source of truth for all the data in our Snowflake database, and our analytics team has built a process to ingest all the transactions, all of the blocks, and curate these views in our Snowflake database to make it easy for users and now AIs to use our data. So after the customer gets access to these tooling, they need to pay us for all of our hard work. And since we're a Web3 company, we do that in a little non-traditional way. We usually take what's called the delegation from one of our partners, which is them taking an allocation of tokens, locking it to our validator, and then every time our validator participates in consensus, we earn a small little reward. It's kind of like you put savings in a account, and then you get a certain APY, and you accrue all the rewards from that. And it's kind of similar where, based on the amount of tokens that you have locked to your validator, you get more rewards. So with this being understood, it became clear that observability was not a day two optimization for us, but it was a hard day one requirement. Because if one of our nodes goes down, then that means the company's not getting paid for all the hard work that the other team set out to do for our clients. So some of our goals here for infrastructure are, we need to make sure everything is alive 24/7. If our RPC nodes go down overnight, that might mean a customer in Singapore who's trying to look at our data doesn't have access to the most recent transactions and blocks onto the chain. If our validator goes down, well, we're losing every single block that goes by while our validator is down. We're losing that reward revenue from that. So now I want to talk a little bit about where we started and how we ended up at Grafana Cloud. So when our team first started, we were a small team with very limited budgets. We had access to some bare metal nodes that we used to run our blockchain services, but we didn't really have a lot of spend for vendor products like observability tooling and that kind of thing. The other teams in our organization were using Datadog, but when we started ingesting into that, we found the costs were too much for us to maintain at this early stage of our team, where we didn't have the revenue impact yet to actually demand those kinds of costs. So I kind of went with what I had been using in the past on my home lab at previous jobs, which was open source Grafana. Just install the Prometheus operator, install Grafana, and you got yourself a pretty good alerting system set up. We also threw in Thanos as our back-end metric store, so we got that nice distributed storage, and used PagerDuty for the paging functionality to make sure we got someone's attention if something happened at off hours. And we used this for probably the first year and a half, 2 years of the team's operations. And we started to develop a pretty good understanding of the pain points of our platform, the observability benefits, and we had a much stronger understanding of the actual business logic that we wanted to define our alert conditions on. So some of the things that worked well with this architecture was that it was fast. Everything was running on a local Kubernetes cluster with NVMe storage. So dashboards loaded quickly. It was very easy. You can run queries really fast, and it was overall a snappy experience. PagerDuty is a SaaS application, so unlike everything else, I couldn't take it down by shipping bad config, which I've been known to do more than a couple times. It had a really simple integration with Kubernetes, the Prometheus operator. You just install it, and then many applications come pre-tooled with all of the Prometheus rules and the metric scrape integration. And it gave us kind of an easy cost model because we knew based on how much raw storage our metrics aggregation is using, what the percentage of our cost was allocated to metrics. But that also came with a couple of pain points. The biggest thing for me was that when we were using Grafana with PagerDuty, there was oftentimes a Grafana way to do things and a PagerDuty way to do things. And that made it kind of hard to develop like the right best practices that we wanted to use for all of our different applications because there wasn't a lot of clarity on like what the better direction was. We would end up in situations where maybe one application was doing this the PagerDuty way, and then one was doing it the Grafana way. It was hard to manage all the configuration as code to keep everything in sync. And it was just overall kind of hard to mentally model because like you have your alerts in Grafana, then they get transformed to a different format in PagerDuty, and you got to figure out how to do all the routing you want in both systems. And running Thanos, while it was easy to install the Helm chart, we found out experimentally that keeping it running long-term was not nearly as easy as that was. We were constantly having to deal with like crashing pods with resource requirements, and it became very challenging just to keep the core monitoring stack online, which we didn't want to have to do because that's what keeps everything else online. So that's how we landed on where we are today. After we had all that understanding of kind of like what worked and what didn't, the opportunity when the other team started getting priced out of Datadog to migrate the entire organization to a unified observability stack. And Grafana Cloud had a lot of the features that the other teams like from Datadog. It was a SaaS product that was always going to be up for them. It was easy to use, easy integrations with like common development tooling. And then on my team, we already had all the experience with the open source Grafana, so it made sense to use that as kind of our universal solution for all observability at Flipside. And you'll see on this graphic, our architecture is considerably simpler now than it was when we were using the open source setup. I kind of look at it as we have 3 different components. You have your workloads. They could be on bare metal, could be in Kubernetes, it doesn't matter. Alloy is the single thing that talks to all of the workloads and makes sure the availability data is in Grafana Cloud. Then we actually have the observability application itself, Grafana Cloud, that looks at all the observability data. You can visualize it, make alerts, all that fun stuff. And then the last part is the notification channels, where we previously had email and Slack, but now instead of PagerDuty, we're making use of Grafana IRM, which allows us to model our entire alerting pipeline from metrics collection to the page on the engineer's phone entirely inside of the Grafana platform. And we immediately noticed tons of gains from using this. So first of all, management now knew if I want to look at something, I go to Grafana because that's where everything is. There's no looking for documentation that doesn't exist, which URL to log into, trying to get the shared password for this or whatever. It was all in Grafana Cloud, all easy to access for everyone at the organization. And like I mentioned previously, we no longer had to deal with the split brain problem of having both Grafana and PagerDuty. Everything was managed was done the Grafana way on the Grafana platform. And one of the problems that we had early on, back when we were first doing our Datadog evaluation, is we had no idea which metrics we needed and which metrics we didn't need. So it was hard to control costs by doing like drop relabels and all those kinds of ways to reduce your number of active series. And then with Grafana Cloud, it turns out you don't need to because adaptive metrics looks at what you're actually using and then allows you just to check off a couple of rules. And then for us, that meant getting 32% of our metrics that we weren't using at all off our billing to keep costs as low as they can go. So now I want to talk a little bit about some of the best practices that we've developed for kind of our day one alerting operation system. So I'm sure many people in this room have gone through what I call the easy part. You get your Grafana Cloud instance set up, You get Alloy or the Prometheus operator set up and the metrics are flowing. Maybe you get some alerts going to a Slack channel, download a dashboard, and it's great. You can see everything, and it's awesome. But now we have to handle what I call the hard part, which is trying to strike that balance between alerting too conservatively and potentially missing critical alerts, and alerting too much and eroding trust of your on-call engineers because they won't know, is this a real alert that I have to respond to, or is it just noise and I can go back to bed? So the first kind of specific best practice I want to talk about is defining a standardized label scheme. Because by defining this, it makes it a low cognitive task to know how to identify future alerts as you add them. You know that you use the team label to identify what team something belongs to. In our case, we use the chain and the network label to identify which blockchain network something's a part to. And the way I look at it is kind of like a hierarchy where your metrics originated in an application, they have all the labels the application attaches, then Alloy comes in and you can apply global labels to either the scrape job or to the entire Alloy instance, which might be a specific Linux node or a full Kubernetes cluster. And then the alerts, you can add labels to that apply the semantic meaning to the specific alerts. And I want to zoom in a little bit here on the specific labels that we use for the alerts, because I think it added the nuance in these really helped us unlock our alerting setup. So we use a combination of, here, sorry, you can take a picture. We use a combination of two alerts at Flipside, Severity and Urgency. Severity is kind of what most people expect it to be, the business logic about a alert. Does this have for us, critical means there's an impact on revenue. Error means something's not operating the way we expect it to. Warning is something looks like it's trending in a bad direction. And then info is something we want to be made aware of, but that doesn't necessarily require any kind of action or response. And by using these two labels, I look at it kind of like a matrix where we have the severity, and then each one also has an urgency toggle in it where we have either urgency high or urgency low. And when you combine these two, that gives you 8 unique kind of use cases for the different alerts you can define. So in even kind of more esoteric ones, like a low urgency critical alert for us is something that's revenue impacting, but there's nothing we can do about it. Like maybe a big customer moved the delegation off our node. Well, we got to tell people about it because that's like very important, but we can't move it back ourselves, so it wouldn't be worthwhile to wake someone up at 4 in the morning for that. So now that we have our labels defined, I want to talk a little bit about how we handle alert routing. So the first thing we do is we use the team label. Every metric that gets collected has a team assigned to it, so that way we know which team owns the service and is therefore responsible for all of the observability data on it. This is used not just in alert routing, it's used in our dashboarding and our billing. Everything we collect, we make sure to identify with the team. So that means the first branch in our alert routing tree, we make sure that the blockchain alerts go to the blockchain team, and then the data alerts go to the data team. So that way there's full tenant isolation between our teams, and we can keep adding on to new teams without having to adjust any of the settings for the previous one because each tree is sandboxed in its own environment. And then the next thing we make happen is we send all of our alerts to the Flipside agentic system, which we're working on building webhook support for, so that way if we get an alert on one of our blockchain nodes, our system can actually look at the on-chain data and figure out more context about what's going on and then enrich the alert with the information that I can find from the on-chain data. And then after that, our alerts go through the normal pipeline where you can see at the bottom, first we look at severity, and we pull out all the severity equals info alerts, because those are not actually incidents that we want to use IRM to handle. We might just want to send an email or send a Slack message to a certain channel. So you can see that we use severity to grab the info and then fork it again on urgency. So we could send the high urgency info to like our main team channel, and then the low urgency ones to a less used alerts channel, so that way people can look at it at their leisure. And then all the severity higher than info, that goes into what I call IRM land, which now through AI we can visualize. How great is that? So this is what IRM land actually looks like, where now we have a separate routing tree for just the alerts that flow from regular Grafana alerts into IRM. And the endpoint on every routing tree in IRM is an escalation policy. And this is where you actually encode the logic of who you want to bother when. And if you think back a couple slides when we looked at that severity by urgency matrix, each of those use cases we now define as an escalation policy, so then in our routing tree, it becomes very easy. Branch on the severity, and then branch on the urgency, and that gets you to the correct escalation policy for the alert classification. So now, if I'm adding a new alert to one of our systems, all I do is define the alert, add the severity, add the urgency label, and it will start routing all the way to the right engineer who needs to get that page. So with that kind of handling our day one observability requirements, I want to talk a little bit about some of the day two optimizations that we've now been able to do since we have our alerting stuff locked down in Grafana Cloud. So one of my personal favorite features is the incident management that IRM provides, which I find really cool because IRM already has the concept of an alert. So you might be asking to yourself, how is an incident different than an alert? And the difference is in the audience that they're intended for. Alerts contain the technical details that the technical staff gets when they respond to a page. And an incident is what communicates with our stakeholders what's going on, what business functions are impacted, who's working on it, and any other updates. So if we look at our Slack notifications, you'll see on the right side, that's the page that we get in my team's channels. You'll see it has all of the labels, all the alert metadata. You can acknowledge it. You can add resolution notes. And it's only seen by the engineers working on it. And on the other side, we have the incident notification that goes into our public channel where we communicate with all of our stakeholders. So that way they get a simple view, hey, this happened, we're working on it, we'll update you when it's done. And it makes it super easy to automate the communication because it's not up to someone to decide to communicate. Our system takes care of it for us. The next day two feature that we added was using the service center as a way to view all of our alerts and other information on a service level view. You accomplish this by just adding a service name annotation to all of your metrics and then defining your services, and then you can view everything on a service by service breakdown. And with all this observability in place, and thanks to the last feature I want to talk about, which is the SLO center, we can now see that we've been able to not only improve all of our system's reliabilities, but now we can actually track and show. This has brought us to the place that I always say we want to be for any observability system, where if someone asks me if my systems are operating correctly, I can say yes, because if they weren't, I would have been alerted already by now. Thank you, everyone, for coming out.